Important reactions of alkenes. Let me consider here two important reactions. One is addition of hydrogen halide to alkenes. Another is the ozonolysis reaction by adding O3. Okay, so this reaction is called ozonolysis, and this reaction it is called hydrohalogenation. Okay, so when you consider this a hydrohalogenation, in fact, this has two important aspects or mechanisms, you can say, or the type of reactions. One is called Markovnikov rule. rule. Another is anti-Markovnikov rule. So you can simply call it AMR rule, and this is AMR. It is also called a peroxide effect. So I'll be explaining these three. Okay. So Markovnikov, he's a Russian, Markovnikov, Markovnikov's rule. Okay. Right. Now let me talk about this Markovnikov rule. This is very significant in the case of hydrohalogenation of unsymmetric alkene. And before taking up, let me discuss about symmetric alkene. The alkene can be classified into two: symmetric alkene and unsymmetric alkene. What do you mean by symmetric alkene? Let me consider butene, CH2, CH3, CH double bond, CH single bond, CH3. So here the double bond is centrally located. Okay, so that you have got the even identity. So it is symmetric. Do you understand this? This is 2-butene, right? The second, the double bond is positioned in the second carbon atom, right? Between second and third carbon atom. And what about unsymmetric? Unsymmetric means that is C, 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 C. It is positioned at one side, one corner. So this results the unsymmetric alkene. CH3, CH2, CH double bond, CH2. So this is unsymmetric. Are you able to follow? Because it is not evenly distributed. So let me consider the, excuse me, symmetric alkene. CH3, CH2, CH double bond CH, single bond CH2, 3. Now the hydrohalogenation, let me take HBr. It is going to be added. So what occurs here? This bond will go here and this bond will go here. Okay, so that you are able to get CH3, CH2, CHBr, CH3, right? Suppose if Br goes here and H here, it results the same product only. So in the case of a symmetric alkene, there is no difference in the product formed. You are able to get only one type of product because this is 1, 2, 3. So you pretty know that you know well that you are able to get only 2-bromo product. Okay, so 2-bromo product in both the cases. But let me consider unsymmetric alkene like this: CH3, CH, 2CH, double bond, CH2. Now this HBl is going to be added. So when the H moves here and Br moves here, you are able to get one product, that is CH3, CH2, CH2, CH2Br, right? And the double bond is broken. Actually, this addition takes place across the double bond and the pi bond is always broken. Okay, so it will happen in both the cases. Pi bond, because a double bond consists of two bonds like sigma bond and pi bond. Sigma bond is due to overlapping of what? That is linear, axial overlapping. So it is stronger actually because the extent of overlapping is more. Pi bond is, let me take the pz orbital, another pz. Now when they combine, they form, that is a pi bond like this. It is due to lateral overlapping. So the sideways overlapping where the fittings are very, very weak. And that is why pi is weaker than sigma bond. So when addition takes place, now this pi bond is the casualty. So it is broken first. And that is why you are able to get such type of products. Now let me consider CH3, CH2, CH2, CH2Br. So this is the product. And what about this? This is 1 degree bromide, right? But let us consider another way. For instance, the Br goes here and H goes here. What will happen? That is, you are able to get CH3, CH2, CH, Br here, and then CH3, right? So in this case, you are able to get two bromo product. Are you able to follow? What about this? This is one bromo product and this one two bromo product. So when this reaction takes place in the case of unsymmetric alkene with the hydrohalogenation, what occurs is this product is the major one, okay? And this is minor, right? So it means almost most of the reactions will be taking place in this manner. That is, this bromine prefers to attack the carbon atom having less number of protons. Protons means here hydrogen. Are you able to follow? So here Markovnikov, he states that, that is, when hydrohalogenation takes place in the unsymmetric alkene, the negative part of the addendum, which is the negative part of the addendum? X, that is halide, Br minus. So the negative part of the addendum prefers to attack the less protonated carbon atom. That is called Markovnikov rule. Do you remember this? Okay. So it goes smoothly like this. But in presence of hydrogen peroxide, this reaction is favored, and that is why it's called peroxide effect. Okay, and it's also called AMR, anti-Markovnikov rule, right? Okay, are you able to understand this? So I hope now you should be able to differentiate these two. One is Markovnikov rule, MR. Another is anti-Markovnikov. Markovnikov rule, that is in absence of what? Peroxide. In presence of peroxide, you are able to get anti-Markovnikov product only. Okay. And what is Markovnikov rule? Markovnikov rule states that the negative part of the addendum prefers to attack the less protonated carbon atom. You got this? Okay. Is it clear? So what is Markovnikov rule? Can you tell me?
It is basically that the negative form, which is the highlight, refers to attack the left or the left part where the protons are
Less protonated carbon.
not.
Okay. But in presence of peroxide, this is opposite. So that is why it is called anti-Marconi also. That is it. Okay, got it? Right. Now let me talk about this ozonolysis. Okay, let me explain what ozonolysis is. Write down. Ozonolysis. Ozonolysis. Lysis means we already discussed it is cleavage. So using ozone, you are cleaving the bond, especially the double bond. Let us consider CH3, CH, double bond, CH2. What is this? Propene. Okay, CH2. So here, this ozone, it penetrates both the bond. Ozone is O3. It penetrates both the bond. It is not like hydrohalogenation where pi bond is broken. Here, both sigma bond and pi bond. Okay, the double bond almost it is penetrated by this ozone. So you are able to get CH3, CH, right? And here you are able to get O. Okay, so now you have oxygen here. Do you understand? And followed by that hydrolysis, you are able to get, okay, now it breaks like this. So you can put here H2 so that you are able to get minus H2O2 as product, peroxide, hydrogen peroxide. The remaining is CH3, CHO, CH double bond O plus here.
What's happening in the
Say,
outside?
no, 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 no. That it is totally different. It is not in the presence of peroxide. Here it is because of the attack of ozone. That is left. That is over. That topic is over. Now we are discussing about ozone layers. That is a different scenario, right? It has nothing to do with the presence of hydrogen peroxide, etc. No. So we are talking about the ozone layers where ozone is attacking the double bond. The ozone is very sensitive to double bond. You could have seen these rubber products, where you can find some breakages here. Okay, it is because of the ozone attacking from the, weather. Okay, so in our atmosphere, ozone is available in plenty, so it will attack the double bond. So in rubber products, you have got it is nothing but isoprene unit. So you have got that double bond, and these ozones are very sensitive to double bond. Wherever double bond is there, it will go and break it, and that is why in fact, we can call it this is something because the yin is affected here. That is, double bond is affected here because of the ozone. So that is why ozone studies are useful to determine or to identify the location of the double bond also, right? So what is the main application of ozone? To locate the double bond, where the double bond is present, because you can see that the ozone will attack there, right? So you are able to get what CH3, CHO and CH2. This CH2O can be written as HCHO. So you are able to get formaldehyde, formaldehyde, which is nothing but methanol. And what about this? This one is acetaldehyde, right? So both of them are aldehydes, that is carbonyl compounds. So using this ozonolysis, what is the main application of ozonolysis? You are able to get the carbonyl compounds. Are you able to follow? Sometimes they may ask you the question like this. They will give the product and you are supposed to find out what could be the alkene. So you have to adopt some reverse engineering here. Let me explain how to do that. Take down this question. An alkene, when it is subjected to ozonolysis, it forms ozonide followed by hydrolysis. It gave 2 moles of acetaldehyde. Find out the alkene. This is the question. Okay. Now I'll tell you how to do this problem. This is not a reaction, but is a re-engineering only, reverse engineering. Now let me take this. This is the product. So let us take this CH3 and put CH, face the double bond O each other like this. Take another molecule CH, CH3. Okay. Now keep these two aldehydes face to face, especially the O, and you can combine this O so that you can introduce the double bond straight away. So CH3, CH double bond, CH single bond, CH3. Now you can declare the alkene is nothing but 2-butene, right? Now we have to verify whether our answer is correct or not, because on subjected to hydrolysis, uh, when you take this alkene and subject to ozonolysis, whether you are able to get the same 2 moles of CH3CHO. So how you can do this? You have CH3, CH double bond, CH single bond, CH3. Now attack the ozone. Okay. So it penetrates the double bond so that you are able to get ozonide CH3, CH, and put O here and CH, then CH3, and then O, then CO. That's all, right? Make sure the valency of carbon 4 on each carbon atom. Now you can split this using water so that you are able to remove H2O2. Okay, H2O and O, H2O2. The result is CH3, CHO, right? Plus another CH3, CH2. So you are able to get 2 moles of acetaldehyde. Got it? Okay. Shall I give you one more sum like this? Yes, sir. When an alkene is subjected to ozonolysis, next sum. When an alkene is subjected to ozonolysis, it gave 1 mole of acetaldehyde and 1 mole of acetone. What is the alkene? Right? Yes, we do. Yeah, tell me. So 3-methyl 3-methyl butane 2-ene. Okay. Now let us check. So how to write down this 3-methyl? 1, 2, 3, 4. And you said 2-ene. So if it is 2-ene and where is the third carbon atom? This is the third carbon atom where you have CH3. Now this is CH3, CH3. This is CH. That's all, right? So it means now the ozone is here, is going to attack the double bond so that you are able to get CH3, CH, and then O, CH, C, CH3, CH3. Now you have O here. Okay, so it means you are breaking like this so that you are able to get H2O, mole of H2O2. So CH3, CH4, double bond O, that is acetaldehyde. Plus, what about this? CH3, C, and then double bond O, CH3, that is acetone. So your answer is correct. It's verified. Okay. And how to do this? What about you? Yeah, what you can do is take this acetaldehyde. What is acetaldehyde? CH3, C double bond OH, right? So as I already told you, you have to take the carbonyl group, C double bond O group, face to face. Okay. And then you have CH3, CH3, right? So what is this? Acetate. What is this? Acetaldehyde. Now you can combine these two oxygen so that you are able to get CH3, C, H, and then double bond C, CH3, and then CH3. That's it. Got it? Okay. So I will give you some worksheet based on that. You can try this. So ozonolysis. I hope now you should be able to understand that questions asked in the question paper. Trisha? Glyoxal. So I will discuss that one. Glyoxal is nothing. What is the question asked? Tell me.
Covered bonds and productive original is produced cancer
Ah,
and
mm,
treatment making of
okay. So the hydrocarbon containing two double bonds. Instead of one double bond, the hydrocarbon, it has two CC double bond. Okay. And then this double bond on reductive ozonolysis produces glyoxal. This produces on ozonolysis glyoxal. Then ethanol, okay, ethanol, and then propanone. Propanone is nothing but acetone, right? So let me derive the structure here. Let me draw the structure. Glyoxal is nothing but CHO, single bond CHO. This is called glyoxal, okay? And ethanol, right? So ethanol means CH3, CHO. This is ethanol, okay? Right? And you have another compound propanone, that is CO, CH3, CH3. This is propanone, right? Which is nothing but acetone, propanone. Now, on which, in which, aldehyde or carbonyl group, you have the double bond facing both sides, glyoxal, right? So
yes,
you can write like this: C C H H double bond O double bond. Okay. Now fix this acetone here. O C CH3 CH3. Got it? And what about acetaldehyde? That is ethanol CH3 C double bond O and then H. Now you can combine this. Okay, this is not a chemical reaction. This is a very idea, that's all, to obtain the alkene. Here alkodiene. So CH3, CH. For this combination, you must put double bond CH and single bond CH and then double bond C, CH3, CH3. Now you are able to get the diene. Is it not?
yes, sir.
What is that diene?
Yes, sir.
What is this diene? 1, 2, 3, 4, 5, 6. Hexa. Hexadiene and methyl group is substituted. Now you can start from here. 1, 2, 3, 4, 5. I'm sorry. 1, 2, 3, 4, 5, 6. So what do you call this compound?
To co-
2-methyl.
to
Start from
methyl,
here.
it will be 2-methyl hexa
Hexa.
2,4 diene.
Very good. So 2 comma 4 diene. Okay. So what is this? 2 methyl. Take down 2 methyl and then
Hexa
hexa 2
2
5 4
Horse,
Die.
die.
That's it. Okay. Now let us check whether we are able to get these compounds. That is the verification we can do. So let me take this compound CH3, and what is that? CH double bond. Now you have CH single bond, CH double bond, CCH3. Okay. Now
Yes, sir.
let us penetrate because as I already told you, these ozone molecules are very sensitive to double bonds. Do you agree with me? So wherever double bond is present, this ozone will go and attack and penetrates both the bonds. So O, 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 O. It will penetrate. It will penetrate. Right? Now you are able to get CH3, CH, right? And then O. Okay? O, O. Then again CH, and then O, then C, O. Right? Now you have CH3, CH3 with the bonds. Now what you can do, you can break the bonds like this by introducing water. So it takes 2 moles of water so that you are able to get by removing 2 moles of H2O2, CH3, CH, what is that? Double bond O plus, what about this? CHO, that is double bond O, CH double bond O, right? Plus again C double bond O and then CH3, CH3. So we are able to get acetol, CH3CHO. What is this? Glyoxal, CHO, CHO. What is this? Acetone, CH3, CO, CH3, which is nothing but propanol. Got it?
Yes, sir.
Okay.
Yes, sir.
Shanvi, how about you? Are you able to understand?
So can you show the previous question for me?
Question. You want to know the question?
It's the one we did before this. It's algae.
This one, huh? This one?
Yes.
Alkene, when it is subjected to ozonolysis, you are able to get acetaldehyde and the acetone. Now, what will be the alkene, right? So in that case, how we have approached? We have taken 1 mole of acetaldehyde, I have put here, and another 1 mole of acetone I have taken here. So keeping the double bond O facing each other so that we can remove oxygen, and now we are able to get CH3, CH double bond, CCH3, CH3. So what is this? 1, 2, 3, 4. That is buta, butene, 2-methyl, 2-butene. That's it. Okay. And when it is subjected to ozonolysis, you are able to get the same compounds. That is the verification. Got it? Right?
So how do we name this?
This one. No. You mean this alkene, huh? You mean alkene?
Yes.
Yeah, all.
So no.
Yeah. Now listen, listen. You can take like this. Otherwise, you can take a straight chain also. Now you got the substituent. Okay. So 1, 2, 3, 4. Butene. So you can write butene where 2-methyl position. So 2-methyl 2-butene because it is in the second position
So we name it without the O.
without ozone. Which one?
No, sir. I mean, yeah. We name it for the ozone next. Yeah, and that's how we really have.
What's your doubt?
So I was asking, how do we get the alkenes?
Alkane. Yeah, alkene is this is what the alkene. So that is by combining these two. Okay, this is not a chemical reaction. This is only a reverse plan. That's all. A scheme, you can say. This is not a reaction, but this is the reaction. We verify by the help with the help of this ozonoid reaction. Okay, so this is only a schematic representation. It has nothing to do with the reaction. Don't think that these two oxygen combine and release as oxygen. No, 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 no. Okay, got this? This is only a schematic representation to obtain the alkene. Got it?
Yeah.
Right. So we will continue in the next class, and meanwhile, I will give you some short worksheets based on ozonolysis, Markovnikov rule, and anti-Markovnikov rule. Okay. So whenever you attempt the multiple choice questions, you please work out on your worksheet. Okay. Consider this as a worksheet. Uh, don't assume any answers. Please work out the problems and find out the answer. Right? Okay. So see you tomorrow. And I think tomorrow being Sunday, okay, so there will be some small test. I will conduct the test once again in uh, hydrocarbons, IUPOC, and this time I will include these two also, whatever we have discussed so far. Okay, Trusha, are you ready?
Yes.
And I will give you one small exercise before that. You are giving this before starting the examination. Please take down. So what you are supposed to do is you have to get me the worksheet like a sketch note. For example, you start you can treat this as a cheat sheet also. You start with alkane, alkane, put alkenes and alkynes. Okay. Now what you are supposed to do is write at least 10 names. One, two, three, four, 5, 6, 7, 8, 9, 10. So what is the first? And you have to write down the general formulas here. CnH2n plus 2. What about this? CnH2n plus, what is this?
CnH2n.
That's all. And what about this one? CnH2n
Minus.
minus 2. Okay. So based on that, what is the first member? CH4. Second member, and you must write immediately methane. Okay. Then CH3, you have to write like this, CH3, CH3. Okay. And what is this? Ethane. And subsequently, you can introduce the, when it exceeds the 3 carbon atom, you can use bond line formula. So CH3, CH2, CH3. What is this? Propane. But when you come across propane, you can go like this, CH3, CH2, CH2, CH3. Correct? One, two, three, four. What do you call it? Butane. Okay. And what is the next one? One, two, three, four, five. So what is this? Pentane. So likewise, you have to complete the entire CnH2n plus 2. Up to 3 carbon atom, you can introduce this kind of nomenclature. But after that, you are supposed to give only bond line formula so that you can make it more, I mean, much easier. Then what is the first starting compound for alkenes? It cannot,
C2H.
so it starts from C2 only. So CH2 put double bond. Okay, so you can fix always in the first position and for example, 5, pentene. So pentene is what? 1, 2, 3, 4, 5. One pentene, you can take only one pentene, no problem. Okay, got it? So likewise, you can continue all these things. Similarly, alkyne. So for butane, what is the compound? One, two, three, four. Butane means three copper, three double, I mean three bonds, right? Do you understand? So you complete these hydrocarbons, that is one. And second, take haloalkanes, that is RX here, and take only six carbon, six members, only six members. Okay, up to halohexane you can do it. Then you can take alcohol or CH2OH. Okay, similarly you can take that is RCHO, that is alkanal. What is this? Alkanal. What about this? Alkanol. Okay, and what is this? Haloalkane, right? What is that? Haloalkane. So for each you have to get me six members, right? And you take COOH or COOH, right? So here you can start with HCOOH, right? That is the first compound. Okay. So carboxylic acid. So C RO or COH means carboxylic acid. So what is this? Methanoic acid. And a common name, formic acid. The trivial name is formic acid. So likewise, you have to put six members. Okay. Got it? And you have to take amine or NH2. What is this? Alkyne amine. So for which you have to write start from CH3 NH2 and complete this. Okay. So how many I have given? That is 1, 2, 3, and then 4, 5, 6, then 7, 8, and you can also add ninth one, that is RCONH2. What do you call it? Amide. Okay. For example, HCONH2. HCONH2 means methanamide. Okay. Right? Methanamide. Okay.
Yeah.
Got it? So likewise, only six members. Then finally, you can take up the ester. Always methyl ester, that is easier for you. So you can put ester. So what is the formula of ester? RCOO or you always maintain this R as a CH3 and based on that you can write. For example, I will tell you CH3, COO, CH3. What do you call it? Methyl and this one acetate. But that is not iupoctane. What is iupoctane? Ethanoate. So methyl ethanoate. So likewise you have to produce. Okay. So you have to complete all these 10 important molecules. This one, methyl ethanoate. 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 Okay. Right? So try to complete all these 10. And if you are quite conversant with this, then it will be very easy for you to um, study organic chemistry as a whole. Right? Okay. Okay. So make it as a neat one presentation. And tomorrow, both of you are giving some idea about this. I think I will take this as a presentation. Okay. And after that, we will be, meanwhile, I will be sending some worksheets also. So try to do that.
Yes.
Right. See you. Bye. Hmm.
See videos and for doubts, can I and send it to you tomorrow,
Yeah,
right?
you can send it. After all, you got Telegram chat, so you can make use of our Telegram chat channel and just to write down and take a snapshot and send it. Okay. Right. Okay. Bye.
Thank you.